Hello guys. Okay, in this video, I will introduce you to another one type of force which is not very common among you. Okay, it is quite a new force that will be introduced to you. It is something that we call as centripetal force. Okay, so if you have your textbook, you may turn to page 87, 88. Okay, so there is a picture there, a picture of a satellite revolving or orbiting the earth. Okay, so in this diagram, it is given that the speed of the satellite is uniform. Okay, so it is moving with uniform speed, uniform speed. So maybe the speed, let's say it is about 400 kilometer per second. Okay, so that is the speed. So that's mean here the speed is 400. Okay, sorry. Okay, so the speed is 400. So at this point also 400, at this point also 400 kilometer per second. Okay, the speed is not changing, it kept constant at every point on the orbit of the satellite. Okay, so if you look into the direction, okay, what can we say that the direction, although the speed is uniform or although the speed is the same, but the direction of the satellite is keep changing. Okay, at this point, let's say at this point, okay, the direction of the satellite is in this direction. What happened if the satellite is on this position? So the direction change in this direction. Okay, anything, okay, any object that move in a circular path. Okay, we have circular path. Okay, so let's say this is our object. Okay, so it is moving at this instantaneous point, it will move in this direction. Okay, what happened to direction if the object is moving or is positioned at this point? So this is the direction. Here, 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 this is the direction. This is the direction. So you can see that although it is moving with the same speed, but since the position is changed, or although the position is changed quite small, but the direction will be changed. That's why we see that, okay, although the speed is uniform, okay, direction always change. Okay, always change. So the direction of this motion, okay, always change. So this kind of motion we call it as circular motion. Circular motion. So what can we say if we have an object moving with circular motion or uniform speed? Okay, the speed is uniform and the direction always change. Okay, so again, something that moving with uniform speed and direction change, we say that it is moving with change velocity. Okay, so velocity, again, look back at your definition. Velocity, it is speed plus its direction. Okay, direction. So speed will change. Speed. Okay, let's use other color. Okay, speed or the velocity can be said that it is changing changing when one, okay, when one of these physical quantity being changed. Okay, so if the direction is changed, so we see that the velocity is changing. If the speed is changed, then we say that the velocity is changing. So in this case, okay, in this case, speed is uniform, but the direction is keep changing. So that's mean velocity. So velocity is changing. Okay, velocity is changing at every point on this circular path. Okay, so at every point on this circular path. So this is the path of the satellite. So based on Newton's second law, okay, Newton's second law of motion, an object when it is moving with different velocity or with changing velocity. So that's mean it has, okay, when there is difference in velocity, so it should be, or it can be said that it is moving with an acceleration. Acceleration. So although the uniform is the speed is uniform, okay, 400 kilometer per second, for example, for each point, but the direction change, so we say that it is moving with changing velocity. In other words, we can say that it is moving with an acceleration. That means these objects that we have, or this satellite orbiting the Earth, is moving with acceleration. It is always accelerating on each point of the orbit. Okay, so that is how can we relate, okay, or how can we say that this satellite or any object, okay, it is not just only a satellite, we can say any object, if it is moving on a circular path, okay, okay, the motion is in the state of acceleration or accelerating. Okay, it is always accelerating. Okay, now we try to relate the acceleration with the force. Okay, so based on the Newton's second law of motion, we have F equals to ma. Okay, F equals to ma. So what does it mean? If an object is moving with a value of acceleration, okay, or if an object is accelerating, so there must be force behind the motion. Okay, there must be force behind its motion. So this force, okay, this force which make our satellite here, or any object, okay, any object moving in a circular path, so that force, okay, that force, we call it as centripetal force. Okay, so the force that makes this object accelerating or moving in a circular path, okay, the force that we call is centripetal force. Okay, an object in circular motion always experience change in direction. Since there is always change in direction, although the speed is the same, so there must be a force acting on this object, and this force we call it as centripetal force. Okay, the direction of this force is always towards the center. Okay, is always towards the center. Okay, centripetal force. Let's say this is our, okay, this is our planet. Okay, where is my planet? Okay, this is our planet. Okay, so this is our planet, and this is the object. Okay, this object, it is moving exactly on this orbit. Okay, so that's mean the direction always changing. Okay, always changing. So on each point, we can see that there is a force. Okay, there is a force acting on this object that we call as centripetal force. Okay, centripetal force. Okay, so for that purpose, okay, for that reason, okay, we come up with an equation, F equals to ma, and if you learn it later, maybe in your form 6 matriculation or in university, okay, but for your KSSM, okay, it won't be included. But v square over r is the radial, is something that we call as radial acceleration. Okay, radial acceleration. So it is an acceleration. So based on this one, F equals to ma. Okay, so this is F towards the center, and m is the mass. So E, we can, with the acceleration, we can substitute with this value v square over r. So we will get this equation for our centripetal force. Okay, so now you know what is the centripetal force. It is a force that acting on an object which is moving on a circular path, and the direction of the force is always towards the center. The equation that we use to calculate the force is equals F equals to mv square over r. Okay, that's all for centripetal force.